Welcome to this final session of this day. I think it's the final session, right? And could there be a better way to end a day as with something as exciting as Blazor? I don't think so. So thank you very much for coming. I'm really looking forward for the next 60 minutes. 60 minutes of Blazor. Now, in this talk, I would like to be a little bit flexible. It really depends on your existing knowledge. And this is the first question that I would like to ask you. Who has never really heard of Blazor and needs a little bit of intro to understand what Blazor is all about? Okay, approximately half of the room. Okay, so I will do a short intro of Blazor, but I would like to really focus this talk on new developments. What is new? What has changed since ASP.NET Core 3 came out? What has changed since last year when I was already presenting Blazor to you here at Techorama? And then we will do a bunch of live coding where I will sweat a lot and you hopefully will not make fun of me if I do something wrong. But first, let me quickly introduce Blazor. I didn't create slides for that. I would like to talk a little bit about it, and I would like to simply run an example. Let's run this example. It's pretty much a website. Looks like a website. In this case, it's my Starship Traveler sample, a sample that I've created for Blazor demos already a while ago, and I keep it up to date. If you want to take a look at it, look at my GitHub repo, you will find the sources. And you see it looks like a regular web page. I can click on it and I can see, oh, Mr. Optimus Prime traveled from Cybertron to Earth, and I can switch between past travels and upcoming travels, and I can make a little bit more interesting visualizations to see from which planets we can travel to planet Earth, and we can do some CRUD operations. Looks really like a regular website. And if I press F12 and I go here and I look here, I see it's just a website just as we are used to. The big difference is the code behind this website is running on the client side and it's written in C#. That's the simple promise that Blazor makes. If you like C#, if you love .NET, and you don't like that much JavaScript and TypeScript, and you would like to stick to your favorite programming language, then Blazor might be your way into the browser. This was the whole idea why Microsoft came up with this project. Now there is a big enabler working behind the scenes. Blazor is, if you want, standing on the shoulders of a huge giant, and this giant is the Mono team. The Mono team, the Mono runtime, they have created, I think it was in 2017, a prototype where they showed that .NET can run on top of WebAssembly. WebAssembly is the next giant on whose shoulder we are standing here. WebAssembly is a kind of assembler language that runs inside the browser, and you can compile different languages towards WebAssembly. I've already shown that today with Go. You can also do that with Rust and also C++. And it happens that the common language runtime, the runtime of .NET, is written in C++. So couldn't be easier. Take C++, common language runtime, compile it to WebAssembly, run it there, and boom, we have C# and the common language runtime running in the browser. Okay, granted, it wasn't that simple, but that was the core idea. So the Mono team did exactly that. They compiled the common language runtime from C++ to WASM, they ran it in the browser, and in 2017, we saw Hello World in the browser console. This triggered at a bunch of guys at Redmond, at Microsoft, the idea to build something similar to Angular or Vue or React, but not based on JavaScript, but based on C#. And that was what became Razor in the browser, short Blazor. That's Blazor. It's Razor in the browser based on top of the Mono runtime running on WebAssembly. Now, the last 2 years was an interesting ride for the Blazor team. Of course, they got a lot of attention and people were very, very excited about using C# in the browser. And a lot of things have changed. A lot of things have changed since last year. But for those of you who haven't seen Blazor, you saw my example here. It's pretty simple, but the big difference it becomes visible if we switch to the network tab. Let me reload this sample application, and then we will see in a second what's really going on behind the scenes. Let's zoom in a little bit. You see up there, we see the Blazor WebAssembly stuff. Yes, there is some JavaScript, but you don't have to write this JavaScript. It has been written by the Microsoft guys. Yes, there is some mono JavaScript, but the big thing is this one, this guy, the mono WASM file. This is the common language runtime. Exactly the common language runtime that you know and love, but this time not compiled to any kind of intermediate language or machine language, but compiled to WASM, to WebAssembly. Now the browser, in my case Chrome, is capable of running WebAssembly, and therefore we have the CLR in the browser. And from here on, welcome .NET to the browser. You see the DLLs? These are .NET standard DLLs. The regular binary DLLs that typically .NET is capable of running. But this time, you do not use the core CLR on your server or on your client with WPF or WinForms or whatever. This time, we use the WASM version of Mono to run these DLLs. Just regular DLLs. We could copy them, download them, and could run it in any kind of common language runtime. It just works. Now, you see a bunch of DLLs and, of course, some assets like images and so on. Now, let me quickly show you how this stuff looks like. I will not focus on the Razor syntax and so on because, well, it's kind of boring. You can look that up in the documentation. I would really like to focus on the more conceptual things, the new things, but a quick peek might be interesting. So let me show you the ticket list, for instance. This is what a Razor file for the browser looks like. You see, you have some routing information up here. You have dependency injection here. You have some layouting, kind of master page, where you can import kind of menu and copyright message that should be available on all pages, for instance. And then you mix and match, as you see here, HTML and C# just as you like, as you are used to from Razor, maybe from the server side, for instance, from MVC or things like that. When you compile this mix from HTML and C#, this Razor template is compiled down to C#, a C# class. So from a file which is called ticketlist.razor, we get a class ticketlist. This stuff up here becomes mostly attributes. This stuff becomes static strings. And this just becomes the code inside of the class. If we scroll down a little, we see, for instance, here the code block where you can implement your view logic. It's a kind of code behind. Do you want to separate code behind from HTML? Yes, that can be done. It will become even simpler in .NET Core 3.1, but take a look at the docs. I'm pretty sure you will immediately understand how this stuff works. The beauty is that you really have a component-oriented UI system here. So take a look at this one, ticket card. That's another component written in Razor with C#, and we can extend the HTML5 element list here. We invent a new HTML5 element that we can now use in all our Razor templates. If you think of, hey, can we pass parameters from parent to client, and does it support events, and does it support two-way data binding, and all these scenarios, the answer to all these obvious questions is yes. Okay? But again, I don't want to focus on the Razor syntax because that would just be me demoing things that you can easily read in the documentation. So to make a long story short, what is this Blazor stuff all about? It's a common language runtime compiled to Mono, then a class library which supports Razor on the browser on top of this Mono runtime, and with that you can build highly interactive websites, single-page apps in C# in the browser. That's, to put it short, what Blazor is all about. Now we have some limitations. WebAssembly, not just Blazor, but WebAssembly cannot directly interact with the browser's DOM, with the document object model. So if your C# code would like to conditionally add, for instance, this header2 element here, it needs to somehow speak to to an emissary who can then manipulate the DOM, and this is where still in Blazor JavaScript comes in. So essentially, your WebAssembly talks to JavaScript, and this JavaScript is then manipulating the DOM. We will get back to this point because it is kind of important when we take a look at the latest developments in the Blazor project. So be aware of that. We cannot directly manipulate the DOM, and also we cannot directly talk to the network, for instance. We always have to go through the browser, and if we want to go through the browser, we have to talk to JavaScript. Fortunately, we don't absolutely need to write this JavaScript by hand because the Blazor guys have done it for us. We don't see it. It's transparent. Do you still want to write JavaScript because maybe you have an existing library in JavaScript that you would like to mix with your Blazor stuff? Yes. JavaScript interop works really nice. To give you a short example how that looks like, let me show you, for instance, here in the client application index.html, I just created two very, very trivial JavaScript methods. One is calling window.confirm, the other is calling window.alert. And if I would like to call these JavaScript methods, I can go to, where is it, book ticket here, and down there, pretty simple. I can use the so-called JS runtime, JavaScript runtime. It's just an injected service, just an interface. And I simply call invoke async, give it the name of the method, and that's done. The other way around works equally simple. So if you would like to call C# from JavaScript, that's fine. And with that, you can bring your existing JavaScript assets, your existing JavaScript code to Blazor, or call Blazor from your JavaScript if you would like to translate your applications to C#, for instance. Good. With that, enough of an introduction. Let's go into the slides and talk a little bit about the concepts behind Blazor, how it works, and what has changed, or what recent developments are there. Where is Blazor currently heading towards? Can you use it in production? Is it an Angular, Vue, React killer? We will see. First, let's talk about the flavor of Blazor, which is called Blazor WASM, the WebAssembly version of Blazor. Let me quickly show you a nice diagram. I've spent hours doing the animations on these slides, so hopefully they will be useful. So what you see here on the right-hand side is a web server. If you run a Blazor app, all you need is a static web server, nothing intelligent. Do you want to use, I don't know, GitHub Pages, Azure Storage, or a simple Nginx web server? Something like this works perfectly fine. The browser sends an HTTP GET just like with a regular website to your web server with the static files, and then you send back HTML, index.html, JavaScript, Blazor JavaScript, Mono JavaScript, your own JavaScript, some CSS and images that you want to use to make your website pretty, and that's the important one, WebAssembly files. Important note, your C# code will never be turned into WebAssembly. If somebody tells you that Blazor compiles your C# code into WebAssembly, that's wrong. The only WebAssembly file that gets downloaded from the server is the Mono runtime. That has been created by Microsoft, and it is a C++ compilation to C#. And this common language runtime will later on just-in-time compile your DLLs. To be exact, it will not be compiled. They will interpret the just-in-time, the intermediate language. So your C# code never gets compiled to WebAssembly. Good. Now we have in the browser the document object model. And below the document object model, we have the JavaScript part of Blazor and Mono. These two things, the JavaScript part of Blazor and Mono, they use the Mono WASM runtime to boot up .NET and Blazor inside the Mono runtime inside WASM. I told you, it's interpreted, not compiled. On top is your app. Regular .NET DLL, nothing special. So this is the high-level architecture. So what's going on if the user interacts with your website? Well, I also already showed you the left part is the WASM part. Now at the beginning, when your website loads, the browser loads index.html. Index.html has the Blazor JavaScript. The Blazor JavaScript will talk to the Mono JavaScript, and the Mono JavaScript will boot up Mono WASM, and Mono WASM will boot up .NET and Blazor, and .NET and Blazor will load your application, the main view of your application. That is essentially what's going on. I can show you later on how this is exactly going on, but it's really not difficult. It's just a single method call. If somebody interacts now with your app, or your app decides that it would like to display something, it talks to Blazor. It talks to the Blazor C# part, and this part again talks to the Mono infrastructure, because whatever this WebAssembly stuff wants to do, it needs to go through Mono through JavaScript. Because the only thing WebAssembly can today do with Blazor is manipulate bits and bytes in linear memory. That's all. Somebody has to sit on the other side of the fence, take a look at the linear memory and say, oh, I understand. You want me to change the DOM, or you want me to send a web API request? I get you. I will do that for you. That's essentially what the JavaScript part does. This is this arrow here. Then the Blazor JavaScript part will manipulate the DOM, and if the user clicks, for instance, on the DOM, the story begins from the beginning. Okay, everything starts from the beginning again. Blazor talks to Mono, Mono talks to Blazor, Blazor talks to your app, and your app reacts. I think you get the point. Of course, and one comment. Please note, I made a big gap between the browser and the web server, and there is only one HTTP request going. In reality, a little bit more, because JavaScript and CSS and so on is of course downloaded with separate GET requests, but conceptually, a single request goes from the browser to the server, and then the client is completely autonomous. It works alone. It doesn't need a server. However, only a few applications really need no server logic at all. Maybe if you create a game or something like this, but most applications need to access some data or logic on the server, and this is of course possible. You can have, for instance, a web API. Could be a RESTful web API, could be an OData service, could be a GraphQL service, could be a gRPC, no, not gRPC, that's a different story. Could be WebSockets, whatever. Now, if you would like to call this web API, you can call this web API, but the call is done through JavaScript. So if you use the HTTP client in Blazor WASM, you are not directly talking to the network. You are talking to a pre-configured HTTP client, which communicates in the background with JavaScript, and the JavaScript is then using the browser's fetch API to talk to the web API. That's the important stuff here. Got it? Does it make sense? Fair? Good. Please remember that, because in a few minutes we will see that we have options. It doesn't need to be like that. Now, the big advantage of having a single-page app written in C# is that you can reuse code. Imagine that you have some C# modal information, that you have some business logic that you already have written, or that you will write and you want to write it in C# because you know C#, you love C#. Why not continue using C#? And the whole point of Blazor is that you can reuse this logic and use it on the server side and on the client side. That's the point. You can reuse exactly the same DLL. And I do not mean source code reuse. You can reuse exactly the same DLL. Do you want to use a NuGet package that somebody else has written who has never even thought of Blazor? It's just a NuGet package with the .NET DLL that is useful for you. You can take this NuGet package and it will run in the browser. You don't even need to recompile it. It just works. Okay? So this is the beauty of having C# on the client. If you are into .NET, if you are into C#, you can reuse your existing skills, reuse your existing tools, and reuse your existing code. Good. Let's summarize. This is not a summarize. This is another information that I would like to give you, and it's important. The WASM part of Blazor is in preview. Preview means it's not ready for production yet. For instance, WebAssembly itself is not ready for production. We are not on .NET Standard 2.1 yet. It's still everything based on .NET Standard 2.0. You have very limited debugger experience. Debugging is not that easy. In reality, you will often need console write-line debugging. That's the only way you really can do debugging if you use Blazor WASM. WASM must be supported by your browser. If you have an old browser, like Internet Explorer, or if you happen to have an old Chrome browser or whatever, forget it. It simply doesn't work. You need WebAssembly. You can host Blazor WASM on any static web server. That means it becomes super trivial to host C# code for many, many users, and they download the code and run it on their computer, not on your server. That's important. Of course, you can use very simple and free static web servers like GitHub Pages or Azure Storage. Azure Storage is not completely free, but it's so cheap that I consider it nearly free. If you want to access a web API, you do that from the browser. That means you have to host the web APIs, you have to build the web APIs, you need to think about authentication and authorization, you have to build a web API, otherwise the client cannot access any server-side logic. You are free in choosing your programming language on the server, of course, but to be honest, the beauty of Blazor is to have a single programming language for the backend, for frontend, and for the frontend, so it makes sense to use C# on both sides. Now let's dig a little bit deeper and talk about how the whole rendering stuff in the WASM world works. First, imagine that in your app, you decide that you would like to display something on the screen. So the app talks to Blazor and tells Blazor, hey Blazor, I would like to display something. Okay. What Blazor does, it turns your Razor template, the compiled version, it's a C# class, into a so-called render tree. Let me quickly show you how that looks like. I will go here into the compiled version and let me go to my Starship Traveler sample and go to the client and bin, no, not bin, object, debug, net standard, Blazor, no. Oh, I'm in the wrong project. My mistake. In the components project, object, debug, net standard, better. Razor and pages and ticket list Razor.js, that's the generated C# file from your Razor template. As I told you, what you get at the end of the day is just a class. You see it here. It's a class ticket list, which is derived from component base. And the point where I want to go to is this one, build render tree. What this method essentially does, you don't need to write it. It's generated from your Razor page. Okay? This method, the build render tree method, creates a binary document object model, not the one of the browser, but inside the C# runtime of the Blazor framework. So let's go back. So what happens is the app talks to Blazor, Blazor calls the build render tree method, and the render tree becomes a hierarchy of binary object reflecting the structure of your web page. That is what we call a render tree in Blazor. This render tree is then turned into a so-called render batch. A render batch is essentially a collection of commands that the Blazor JavaScript part understands. It, for instance, contains commands like, hey, create a node of type paragraph and add it to the DOM in this and that position, to simplify it a lot. That is a render batch. At the beginning, the render batch, of course, contains everything. Later on, we will see that it renders only parts, the changed parts of the render tree. Now the render batch is taken from Blazor JavaScript, and the JavaScript part manipulates the DOM accordingly, and boom, we have HTML in the browser. Now the user does something. Your app needs to change the render tree. Hopefully, I will change the video beamer to get the image again. I didn't touch my laptop, I promise. I promise. I spent so much time drawing these slides. I would like to show you the animations. But we have support, right? Should I turn off and turn on again?
I think we've got a problem.
We've got a problem. Houston, we have a problem. Stay for 1 or 2 minutes, okay? Maybe we can fix the problem. Should I plug out and plug in again?
Yeah, try it.
Try it? Okay. Let's do that. Otherwise, I will turn my laptop around and you can all watch my laptop. So, let's plug it in again. Crossing fingers. Ha! That's the ultimate solution for all IT problems, right? Plug out, plug in, and everything is good again. So, now we have to roll back to our last good known state. Yes, I think you have a question, right? Huh? Oh. We are nearly good. Yes, very good. Now we have to roll back to the last known state. What we had was, we had a render tree, and now the application would like to change something. Can you remember the if statement where we add an h2 conditionally? Maybe the expression has changed and now we would like to add something, and that looks like this one. Please note that we just changed here this render tree, so something has changed. Now what Blazor does internally, it takes the old render tree, it takes the new render tree and runs a very efficient diffing algorithm. Yes, you can configure this stuff, and yes, you can do a lot of things to make this even more efficient. Please read the docs to understand the details. Now the render batch does not contain everything and the whole DOM is rewritten. No, the render batch contains only the changed things, and now the JavaScript part runs and changes something in the DOM. That's it. That's the whole architecture. That is how it works. Which part of this logic runs on the server? None. We don't need the server. Everything is on the client. It's a single-page app. Good. Let's summarize, and I would like to give you some additional information. All view-related logic runs on the client. That means, and that's a very good news for you, you don't have to pay for the resources. It's a kind of serverless. What is the best and most, the cheapest server? The server that you don't have to run, that you don't have to build, therefore it's the resource of the client. You don't need to maintain it, you don't need to pay for the CPU, you don't need to buy memory, it's run by the client. If you get 1,000 additional clients, it will auto-scale. You have the best scale-out strategy ever because you get 1,000 new laptops or phones or iPads or whatever your users use. That is serverless. But you have limitations. What kind of limitations do you have? Hey, you're running in JavaScript. You're running in JavaScript, you're running inside the WebAssembly sandbox, and that means no input-output, no access to the disk, no access to a database, no direct access to the network, things like that. And we all know that JavaScript is a single-threaded environment. That means we cannot do parallel programming. You can do async programming. Yes, you can do async await. Yes, you have tasks. But you can also only do async programming. You can never run 2 CPU-bound operations at the same time, even if your laptop that you are using has, I don't know, 16 cores. You're wasting 15 of them. I'm very sorry. It is a real single-page app. Progressive web apps, for instance, with offline capabilities are definitely possible. You could do that. You could add offline support. You can access IndexedDB and things like that. Disadvantage, the client is pretty fat because you need to download the entire logic to the client. And here I have a news for you. In the latest version of the Blazor bits, the intermediate language linker runs over the whole DLLs and removes unnecessary code, unnecessary assemblies, so the code becomes a little bit smaller. But still, we are talking about, for a hello world applications, about megabytes. Of course, you can reduce the pain by compressing the response from the server to the client, but still, we are not talking about bytes or kilobytes, we are talking about the megabyte range that we are downloading. Okay? The compressed version. Good. Now, many enterprises are really excited about Blazor. Why? They have existing .NET teams, they want to go to the browser, and for them, it's not a good news that Blazor is not final yet. They want to use Blazor today. They want to use Blazor today because, well, it provides value, right? WebAssembly is not final, so we cannot change something like that. The Blazor WebAssembly part is not done yet. Things like debugging, there are huge construction sites here in Blazor that we have to do. Therefore, the Blazor team came up with a new idea, with a change of the strategy in Blazor, and this is called server-side Blazor. Let me show you how server-side Blazor works. It's completely different. Server-side Blazor, I would like to do a spoiler here, is in production today. All the things that I show you here are possible today. They work on top of ASP.NET Core 3, and there is no preview software involved. So how does that work? We have a server. This time, it's not a stupid server. This time, it's not just a static website. This time, it's ASP.NET Core 3, and therefore, we have the core CLR. Not mono, the core CLR. On top of the core CLR, we have the Blazor DLLs, of course, and on top of the Blazor DLLs, we have the app. And this app is really an ASP.NET Core 3 app. Therefore, the whole startup process and everything works just as you are used to it. Core CLR starts Blazor, Blazor, or ASP.NET Core. ASP.NET Core spins up your app. Good, nothing new here. On the left-hand side, we have the DOM, and we have the Blazor and Mono. Oh, sorry. That's a mistake, I'm sorry. We don't have Mono JavaScript here. Live debugging of slides here. DOM and Blazor JavaScript. Please note, no WASM, no Mono, no WASM runtime, nothing like that. On the contrary, it works completely different. The Blazor JavaScript establishes a duplex connection from the client to the server over SignalR. This is the ASP.NET SignalR that you maybe know and maybe you love. This is a duplex communication, so the server can send messages to the client and the client can send messages to the server. Blazor sits on top of SignalR and creates so-called circuits. This is just a term that the Blazor teams came up with. A circuit is one connection over SignalR from one client to one server. And with one client, I mean one browser window or one browser tab or one iframe in which Blazor server-side runs. This is a circuit. So therefore, we don't have just one circuit open, but we have a lot of, we have a lot of circuits open. We'll talk about that in a second. When the Blazor JavaScript starts to run, you have the option, I want to emphasize that, to do pre-rendering on the server. So on the one hand side, you can send an empty render tree to the client, or you can pre-render HTML on the server and send a ready-made initial HTML impression of your website to the client, and therefore the loading time will be pretty fast. It doesn't have to download WASM, it doesn't have to download DLLs, it just downloads a ready-made HTML version of your website, an initial version. I told you already, these arrows, they symbolize a lot of client connections. So I think you already got the problem here. Your server will be flooded by SignalR connections, and you have to have a strategy for that. Every single client, and again, I mean iframe, browser tab, browser window, every single client opens a circuit that means a SignalR connection to your server. So very likely, a single server will not be sufficient. So you need a farm of servers. And running a highly available SignalR server farm is not the most trivial thing on earth. Therefore, the Azure guys came up with a new service that works hand in hand with Blazor, the so-called Azure SignalR service. It's a multiplexer for SignalR. It can handle thousands and thousands, if you want hundreds of thousands of SignalR connections, and it's a complete serverless service. So you just say, Microsoft, give me a SignalR hub, and they will run it for you. And it will auto-scale. You don't need to deploy VMs. You don't need to launch VMs. It's just a ready-made serverless service in Azure, and it will multiplex thousands of WebSockets connections to your application within a handful of connections, maybe 5, something like this. So your server only has to deal with a few connections, It still has to have enough CPU power and memory to handle all these connections, but you don't need to scale out the web service, the WebSocket endpoints. Okay? That's Azure SignalR. And if you Google Azure SignalR with Blazor, you will probably immediately find a blog article where Microsoft describes how you can set up an Azure SignalR service. It's really trivial. I think I also have a video on my YouTube channel about that, but I'm not sure. Now, if your app does something, please note, the app is now running on the server, not on the client. It talks to Blazor, and Blazor creates, again, a render tree. But this time, note that the render tree is on the server, not on the client. So we have a complete binary representation of the website running on the server. This was not that complicated because we had a strict separation between JavaScript and the render tree before, but before it was the WASM sandbox. Still, it was linear memory. So what they essentially did, they just ripped apart the web service, the WebAssembly stuff and the JavaScript stuff, and put a SignalR connection in the middle. That is what Blazor server-side is all about. So just as before, we build a render batch, but this time we send the render batch from the server to the client. The client's JavaScript takes this render batch and manipulates the DOM accordingly. If you do something in the DOM, for instance, clicking a button or doing whatever you want as a user, then a message gets sent from the JavaScript part to the server through the SignalR circuit. The SignalR circuit Blazor receives the message, talks to the app reacts accordingly and changes the internal representation of the website, the render tree. And again, we have the same topic. A minimized render batch is sent to the client is manipulating the DOM, and everything starts from the beginning. So what we have is a continuous communication. Every single interaction on the server and on the client sends messages through WebSockets and SignalR. I can read your thoughts. Many of you think, oh, how can that work? What are the advantages? What are the difficulties here? Let's talk about that. But first, let's talk about what advantages you have. Imagine that you would like to access a web API. If you want to access a web API, the big difference compared to before is that you now access the web API from the server side. You never directly call the web API from the browser here. So essentially, it's a call inside of your data center. It's a call from your Blazor server to a web API which does not need a connection to the internet. That's the important thing. And for some companies, this is super important because inside your data center, you might be able to choose different authentication technologies. If you make a web API available on the internet, you have to think about OpenID Connect and things like that. Maybe inside your data center, you can use a more simple mechanism like API key, or if you are in Azure, managed identity and things like that. That makes your life enormously more simple. You can even do dirty tricks. You can do a dirty trick and say, hey, I'm running in .NET Core, so why not directly accessing the database? There are a ton of reasons why you shouldn't access the database directly. I know that. Now, I'm speaking as a software architect. As a software architect, of course, I would like to separate the different domains by microservices and so on. But let's be honest. In many cases, we have to build a department app inside an enterprise, and we have only very limited budget, and we have to get something done. We have to deliver it now. And for such cases, why building a web API at all? If we need to, maybe for a prototype or a very budget-constrained environment, we can directly access the database using Entity Framework or access files directly or whatever we want, because we are already inside the data center and we can do whatever we want because we are not limited by the browser and the WASM sandbox. Get the difference? For some scenarios, I don't say all scenarios, for some scenarios, this is exactly what you want. This gives you the kind of developer productivity that you are looking for some scenarios. Good. What about reuse of the code? Hey, in this case, it's trivial. In both cases, we have .NET Core, so we can just use NuGet packages or shared code or class libraries because we can use them in the Web API and in ASP.NET Core. And the beauty here is that the backend Web API and our Blazor backend are fully supported. They are on .NET Core 3, so you can use .NET Standard 2.1. The latest version of .NET, the latest version of .NET Standard, and the latest version of C# 8. You are not limited to any kind of limitations that Blazor on the client in WebAssembly gives you, so you are not limited to .NET Standard 2.0. Important thing. I know it will go away, probably in a few months, but still, it is a limitation as of today. Let me give you a little summary and some additional information. So, server-side Blazor, ready for production. You can use it today. It launched with .NET Core 3. Next one, no WASM. It works on all browsers. You don't need WASM support. You, of course, download much less data, much less code to the client because all you need to download is a little bit of JavaScript. No WASM file, no mono runtime, nothing like that. So probably your app will load initially faster. If the app is faster afterwards in a kind of stable state, it depends on the network, because it will be a pretty chatty website. It will talk a lot to the server. So if we have a low latency connection, for instance, inside a local area network, and we have a strong bandwidth, for instance, in a local area network inside an enterprise, it will probably be pretty fast. Will it work nicely and blazingly fast over public internet with a limited Wi-Fi connection? Probably not. Of course not. That is what I meant. It depends on a fast and reliable internet connection, and that means this way of working with Blazor works great for intranet apps and enterprises. It works not so good for public consumers who might, for instance, use their mobile phone to consume the app. And you need a server. You need ASP.NET Core on the server. That's a very important one. The server runs the view-related logic. That means you have to pay for the server. If you are in Azure, like I am for 10 years now, you have to pay for the Azure servers. You have to pay for the multiplexer. You have to pay for the memory. Every single browser tab, every single iframe has a circuit and needs memory on the server. And it becomes even worse if a client loses connection. For instance, the user uses his phone and he goes through a tunnel and the connection breaks. This is considered a non-graceful end of the circuit. And that means that the server will not immediately terminate the circuit, but it will keep the circuit for a few minutes in memory because the user might reappear in a few seconds. Get the idea? That means you can end up with some orphaned circuits and they block memory on the server, and therefore you need a kind of strategy for dealing with this kind of situation. So again, a strong argument why you shouldn't use the server-side Blazor in a scenario where you have a shaky internet connection. I already mentioned that one, and you know limitations, I already mentioned that one. Good. Now, we have options, we have limitations, what should we do? What is the best practice for developing for Blazor today? You have two options, server-side Blazor and Blazor WASM. And the thing that I would like to advise you is not doing two different versions of your app. You don't need to absolutely decide which version you want to use, because I have good news for you. You have full support for so-called Razor class libraries inside of Blazor as of today. A Razor class library is nothing else than a .NET Standard 2.0 class library with support for Razor files. So you can put all your Razor files into a common class library and reuse it on the server side and on the client side, and everything works. Well, nearly everything. It's very likely that you have some pieces of code where you need platform-specific implementations. And for that, you should go for abstractions, things like interfaces, abstract base classes in your Razor class library, and then add implementations here and here, depending on your needs. You shouldn't put your core business logic, and your core modal, for instance, in your Razor class libraries. The Razor class libraries should just contain the view logic. The real core business logic should remain in class libraries, in regular .NET standard class libraries, and please keep in mind, as of today, the client-side Blazor supports only .NET Standard 2.0. That means if you want to be compatible with WASM Blazor today, you are limited to .NET Standard 2.0. I'm very sorry, it is like it is, it will change, but currently it is that way. Good. Don't repeat yourself, I told you that. My tip is, if you start with an application today, try to be compatible with both platforms. Use abstractions like interfaces and base classes, and use dependency injection to inject platform-specific implementations. I will use the last 10 minutes of my session to show you a demo about that, okay? And separate the core modal and business logic into separate class libraries. You shouldn't put them into Razor class libraries because they might be used by different UIs, your WPF UI, your WinForms UI, your UWP, your Xamarin, or whatever, or maybe used by any kind of web API stuff. Good. Want to see it live? Yeah, let's go for it. Let's create a new project from scratch and set it up as it should be today, okay? Let's start with Blazor. I'm on Android. Why am I on Android? So let's start again. Blazor. Okay. Let's go this way. File, new project. So. Great. Good. Let's use the Blazor app here. I don't know why it doesn't find it. I don't care. Techorama Blazor Live. And let's start with the client. The question that I get asked is whether I want to implement a server-side Blazor app or a Blazor WebAssembly app. And let's start with the Blazor WebAssembly app and create it. Will only take, hopefully, a few seconds. Here it is. This is our client. It's really trivial. I could start it. It contains just 3 pages, nothing special. Let me quickly show you the project file because that's at least a little bit interesting. Here it is. You see, this is the WASM part, and you see NET Standard 2.0, and here you see a bunch of preview DLLs. That's Blazor for the client. This is what we created now. Now we can create a second project. Let's add a new project here and look for Blazor app here. And let's add a server-side project. Good. Blazor server app. We don't need HTTPS, and go for it. Good. This is our server-side project here on the right-hand side. It looks just like ASP.NET Core. And if we take a look, hooray, it's ASP.NET Core App 3, and this is a project file how it should look like. Really, it's simple, it's clear, no preview, no DLLs, everything is just baked in. The only thing that I have to tell is I would like to do web development, and I would use .NET Core 3. That's it. Okay? This is how the server-side Blazor looks like. The functionality is pretty similar. I could start it. Well, let's do that just so you see the application for one time. Let's go for it. We still have a bunch of minutes. That's good. It's compiling, it's compiling, it's compiling. It's restoring, doing some NuGet restores. Build succeeded. Starts the app. This is how it looks like. I can click on a counter and I can fetch some data. That's it. Very simple. Good. Now this one is the WASM part. It runs in WebAssembly. This one is the server part. Do you see any difference? No. The only difference you would see, let me run the server part because the WebAssembly part was already shown. If you go to network and reload this page, do you see? I just started the WebAssembly part because I forgot to set the startup project. No problem. Let's do that. Good. This is now the server-side part. Looks exactly the same. Now let's run this guy, and do you find any WASM here? No, of course not. What you see is you see here a protocol change to WebSocket. So if I go here in the Chrome Developer Tools and go to Messages, you see the messages here. And if I navigate, you see any kind of navigation that I do sends messages back and forth between client and server. And I can also take a look at these messages, and you see here we have this render batch that I told you about. It's a binary representation, and if I click here, maybe we can find something. Let me quickly see. Yes, this is interesting. This is, for instance, a mouse event with the X and Y positions where I clicked, and some status of the keyboards, whether I pressed Shift and Control. This is exactly what's going on. This is the server-side Blazor that I was talking about. Now, how can we do this kind of development strategy that I told you about? What we can do here is we can add a new project and go for, crossing fingers, yoo-hoo, Blazor class library. Let's call it Common View Logic. Class library, looks good. Go for it. And now we have a new project, and if we take a look at this Common View Logic project, it's a .NET Standard class library. It's .NET Standard 2.0, so that it is compatible with the Blazor part and the WebAssembly part. And the beautiful thing is that we can now simply do the following. Let's delete the stuff that was auto-generated. Get rid of this guy. Get rid of this guy. Goodbye. And just take the program from the Blazor part. I could do it from the server part too. Drag it, drop it to here. Let's delete this one. Goodbye. And go to the server side, and here do exactly the same. Don't need that one. Don't need that one. Don't need that one. Let's call this one, I don't know, Blazor. So now we go to the WASM client and add a reference to our view logic. And then we go to the server part and add a reference to our view logic. And now we have exactly the structure that I was talking about. We have a common implementation of all our Blazor pages in the middle, and then we have the WASM part up here, WASM, sorry for my handwriting, and here we have the server part, okay? We only have a single implementation. We don't need two implementations. On the last slide, or at the end of the talk, I will show you a link to a GitHub repository where you can find a sample that does exactly that, and it's fully implemented. The Starship Traveler sample works exactly the same way. I can quickly open it. You have already seen it. You see, here I have my client-side and my server-side projects, both pointing to the same component library. I have to change a little bit, but not a lot. Now we can add a fourth project for our core business logic. So let's add a class library. Ah, come on. I don't know why it doesn't find it. Let's see. Class library here, .NET Standard. I like that one. So that's our common business logic. Now here we have our common business logic. You see that one? And here you should add your modal, here you should add your hardcore business logic, here you might add your, I don't know, data access layer with entity framework and things like that. And because this common business logic, let's take a look, is .NET Standard 2.0, it is compatible with Blazor client-side and Blazor server-side. Finally, we have to change our dependencies a little bit, so we add a reference to the business logic from the WASM part. We add a reference in the common view logic to the common business logic, and we add it from the server side. And then we are done. So let's quickly draw it, how it looks like. Our client depends on the common business logic, and the client also depends on the common view logic. The common view logic depends on the common business logic. That's fine because it needs the same business models, for instance. That's super important. And the server side looks exactly like the client. So it references this guy here and it references this guy here. So we have two central points: the business logic used by everyone, the view logic used by the client projects, server and Blazor. And with that, we can limit the amount of code that we have to write to an absolute minimum. The last missing piece is dependency injection. In Blazor WASM, you can add services here. So what you essentially would do is you would say services dot add scoped, for instance, and then you would say whatever business logic, and the implementation would be the WASM implementation of logic. You get the idea? And exactly the same would be here in our startup code, but this time in ASP.NET Core. But this is not the WASM implementation, but the server implementation. And with that, we can add an abstraction layer in the common view logic and add two different implementations for the server and the client side, and then we can choose. And that's the point that I would like to make here. Summary. You're ready to go with Blazor server side. WASM, not done yet. WASM was announced at the recent launch of .NET Core 3 for spring, summer 2020, something like this. So you can expect it to come in the next few months. Is it the Angular React Vue killer? No, it is not if you like JavaScript and if you maybe even use Node.js on the server. So if you are into JavaScript development and you are looking for a super functionally rich platform that is mature, that is here today, you will probably not take a look at Blazor. But, and this is the important one, if you are a strong .NET lover, or your team has a lot of developers who know .NET, existing skills, existing tool chains, investment in automatic continuous integration and deployment pipelines, you simply know how to work with .NET, and you don't have a strong investment into JavaScript, then Blazor can be really an interesting option for you for the future. You can do it today with the server-side part, and if you follow the guidelines that I gave you here, you will be ready for WASM once it will come out, okay? So there is no reason to wait. Now is exactly the correct time to go into Blazor if you have an internal application or if you want to start developing, for instance, first prototypes. And next year, maybe at next Techorama, I will hopefully stand here and show you the production version of Blazor in WebAssembly, and then you have both options, and you can even build an application where you have a little bit of JavaScript at the beginning, and then you decide, oh, this customer is on my intranet, so I will give him the server-side version because that is pretty optimal for this user. And on the other hand, if the user does not come from the intranet, but comes over the internet where he needs possibly offline capabilities, you give him the Blazor version with a single code base. That's the point. Time is up. 60 minutes are so short. I wanted to show you a few demos, but today I especially wanted to focus on more architecture and strategy parts. I hope it was interesting. I hope you learned something new. It was my last session for this year's Techorama. I want to say thank you for having me. Thank you for coming, and of course I will add my slide deck and I will add the recording in my YouTube channel. Just Google my name. My name is not that common, so I'm pretty sure you will find me on YouTube, LinkedIn, and so on. And if you have any questions, don't hesitate to send me an email or a tweet. And with that, I have to say thank you and enjoy the rest of Techorama. Thank you very much.